what's the meaning of the pulse energy? Why for the same 300 watt laser cleaner we have two models? What this will affect the laser cleaning effects? What is energy density? Hello everyone, this is Jelly again. Today I'm going to talk about the relationship between the power and pulse energy of a pulse laser cleaner. Last time we talked about the power of the laser, which I think this concept is quite clear for everybody. 200 watt, 300 watt, and 500 watt, which is the power of the laser. Today I'm going to talk more about the pulse energy. So before that, we need to make it clear what's the difference between power and energy. Power is the rate of the work that has been done, like we're cooking water. You can use a pot that is 1000 watt. So you will cook the water to 100 degrees at half an hour. If you use a 2000 watt pot, then you only need 15 minutes to cook the water into 100 degrees, because you use two different power pot, right? So this is the power. Power is that the rate of the work has been done, which means in 1 second or in 1 hour, how much energy in total. But energy is that when you cook the water from 0 degrees to 100 degrees, all the energy has been involved to make it to that temperature. So this is energy you needed. If you use higher power, you use less time. If you use smaller power, you use longer time. But energy is the same when you finish the work. So the time involved make these two concepts different. Understand? So let's show it on the blackboard. So according to what we said, 300, like for example, the 300 watt laser cleaner, 300 joules is about 300 watt plus 1 second. So power plus the time is the energy we will get. And we have these coordinates. This is time. And this is power. For example, like 1 second. In 1 second, if you set the frequency at 3 kilohertz, which means in 1 second you have 3000 pulses. So you get, this is every single pulse. This is a 2 millijoule pulse, and this is a 5 millijoule. So you have to know that every laser being designed and built, when they deliver to you or when we integrate in a machine, there is two parameters already fixed. You cannot change. One is the average power of the laser, which like 300 watt. So every second, this laser will not generate more than 300 watts, no matter how you play with the parameters. And the other one is the single pulse energy, which is 5 millijoule, for example. So 300 watt, 5 millijoule. This is why when you buy, or when we buy the laser or you buy the machine, we give you the specification of these two. These two parameters will not change, which means it's the limit of the laser. So what does it mean, the pulse energy? So in 1 second, the laser will generate many pulses, and you can set the pulse width, which in the panel of your machine, you can choose the pulse width. This is the pulse width. And the frequency, which means how many pulses you will get per second. So the pulse energy means in this every single pulse, the power plus the time. Actually, it's divided into, like, because the peak power is varied. It can be divided into many sections, but in any way, the total energy is the shade area. So this power probably maybe 800, something like that. I don't know, example. So you will get in total this every single pulse energy is 5 millijoule, and this one is 2 because the space is different. This one is bigger. Okay, so after getting the clear of the definition of power, single pulse energy, now we came to another very, very important parameter, which is power reduction frequency point. And so you have to play the machine according to the laser you get. And even some people probably they use max laser or Raycus laser or IPG laser. So there are many lasers on the market. Besides the cleaning datasheet, you need to know the laser source, which we give you like something like this. A very important parameter, we call it power reduction. Power reduction frequency point. It's difficult to understand, but I will try to make it clear. For example, for the 300 watt 5 millijoule, for example, the power reduction frequency point, there are many groups, not only one group. Like when it's 10 nanoseconds, which is the pulse width. The power reduction frequency point, for example, I'm not very clear now, but just for example, is 400 kilohertz, something like this. And if you go 50 nanoseconds, it's another 100 nanoseconds, like a group this. This datasheet is delivered with the laser, so this is quite important. Many people ask the cleaning datasheet from me. I'm not sure my datasheet will suit you. It's because I don't know which laser you use. So why this is very important? Let's come back to this. So every laser, when they designed or built, they have this, which is like this. This is a 5 millijoule 300 watt laser. So, for example, if this is a power reduction frequency point, which means when you give 400 key pulses every second, and the duration is 10 nanoseconds. In this situation, this laser gives full power 300 watt and 5 millijoule pulse energy, which is the best power of this laser, which means it's full output of the laser. Let's imagine if you go higher than this frequency, like you said 500K, I mean, I gave more pulses in every second. Instead of 400K, you gave out 500K pulses. And we talked about before, every laser will not give power more than 300 watt every second. So if you generate more pulses, which means every single pulse energy will going down. So, which means why we call this reduction point, because in these settings, if you go higher frequency, every pulse energy will go down. If you go lower frequency, like if we deliver 300K pulses per second, if the power will still remain 300 watt, but every single pulse energy will not go more than 5 millijoule. So it will remain 5 millijoule every single pulse, but you have less pulses, which means the average power every second goes down. So that's why we call it power reduction point, frequency point. If you use this setting, you get the highest power, highest pulse energy. If you change the frequency higher or lower, you get either smaller pulse energy or smaller output power. So after we make it clear about the power, the single pulse energy, and the power reduction frequency point, then we come to another very important definition, which is the energy density. What is energy density? The wavelength of the laser working on a certain material, metal, plastic, or rust. So the absorption rate. Different materials, they absorb different wavelength laser with different absorption rate. So, for example, so everything is fixed for laser cleaning. We use fiber laser. which is 1070 nanometer wavelengths, and work on the rust removal. So the material is fixed. The wavelength of the laser is fixed. So what's the difference between the laser working on the material? So what we're playing with the parameters, actually in the end, is the energy density. Like how much energy you delivered to the surface of the rust. There is a focus point. When you're shooting the laser on the piece of metal, you get the dot, a laser. So theoretically, a focal of a laser is a point, but still it's a shape. So it has the space. So if you get a bigger focal or very small focal, you can calculate it. The energy you gave to the surface divided by the space, the square of this beam, you get the density. Like every millimeter, how much energy you put on the surface. So that's why even you use a same 50 millijoule laser, when you came to the point on the material, you get different spots. So still you get different density, which means if you have a sharper beam, you get a stronger removal. If you have a flatter beam, you get a soft removal. So then you understand why we choose single mode and multi-mode. 2 millijoules normally, even is 2 millijoule, same the energy is smaller every single pulse. But you will see another parameter delivered with your machine shows that the focal point, the beam diameter, is much smaller. Because when you see this, when you divide it by the square millimeter, like if the beam is half of this beam, like if you have, for example, if you have 0.1, maybe it's too large, just for example, 0.1 millimeter diameter of the beam, here you get 0.05, for example. It's half of the beam size, but you get four times stronger density compared with this one. So that's why even the single pulse energy is smaller, but you get stronger removal power because you have higher density. So after so many complicated explanation on different definitions, but you need to really make it clear the power of the laser, the single pulse energy, and the power reduction frequency point, and the energy density. These are very important when you play with the parameters of your machine. But actually, you just understand it's okay. You don't need to be really very expert or professional on laser design or building that. You just choose a reliable manufacturer for the machine. They will choose the best laser, the best optics. They will have professional service before selling to you, help you to sourcing out which kind of laser is most suitable for your applications or your cleaning scenarios. So you need to just trust and rely on machine builders is enough. Why I gave this video to explain it in a very clear way is many people ask me. And on the other side, if you understand these definitions, you can play better with your machine. And then, for example, if you want to cleaning wood, you can set higher frequency, so you get lower pulse energy, but you get the maximum speed because you didn't lose power of your laser, but you reduce the peak power of every single pulse. So you can play with that. Then you find the best parameter that doesn't hurt your base material, but take off the service that you want to do. You can adjust a little bit the peak power of every single pulse. So you can lower the frequency. You get the same power to take off the service, but you don't let the laser stay too much on the surface, which means you get less power every single second. So this is just, when you understand this, you know that how to better play with your machine parameters. And you can better understanding the data sheet that I've sent it to you, because always I will send this power reduction frequency point, and looks like useless because many people don't understand why we put this in the data sheet. Now probably you have better understanding on that, and I hope that you can get better working with your machine. Thank you.